Okay, so this video is about the bare minimum needed for Ospf to work within a network. The bare minimum configurations. Now, if you are a beginner, this is a great video for you. This will give you the overview of what is needed, the basics of what is needed to configure Ospf. And also, if you're someone who's just refreshing your mind and trying to remember how Ospf is configured, this is also a good video. I will not be going through a lot of the show commands. Like I said, this is the bare minimum for how it is configured, although we will be confirming that Ospf is up and working. So if you are new and you want to learn a bit more about Ospf, I would suggest going to other YouTube videos with it that are going to be more detailed, but this is just going to be hopefully a 10-minute video on how to configure Ospf. So let's jump right in. So we're going to start off by adding a router. Make sure it's turned off. We're going to add a WIC2T, which effectively has two serial interfaces. We're going to turn our router back on. And our router is booting up. Now what I'm going to do, I'm going to click this again. I'm going to click edit copy. I'm going to paste this twice effectively to copy that router twice that I just configured. Then I'm going to add the links for these routers, and I'm going to use serial links. Specifically, you don't have to use serial links, but this is the link that I'm going to use in this tutorial. So I'm going to connect this serial 0/0 to 0/1 and our 0/0 to 0/1 as well here. Excellent. I'm going to call this router R1. I'm going to call this R3. I'm going to call this R2. Now I'm going to create a third link right here, but this link will not be configured on one of our Ospf interfaces. Okay, so now we have all three routers. Let's do some labeling. This link we're going to use IP address 30.0.0.0 with a subnet mask of 30, and all these links are going to have a /30 subnet mask range on it. Okay, so now that I have a plan, let's jump right into the configurations. Okay, so on R1, I'm going to hit no for that. The enable mode. Let's jump into global config mode. Let's give this a name so that we don't confuse ourselves when we're trying to figure out which router we are in. We're going to call this R1. Now, I'm going to do a command that will tell us what the status of our interfaces is, and that's going to be a show IP interface brief. I'm just using abbreviations, but the whole command is show IP interface brief. As you can see, all the interfaces are administratively down and they have no IP addresses, so these are all clean routers being booted from the start. So I'm going to jump into interface serial mode, and we're going to configure our link between R1 and R2 first, so we can get our links up and running. Okay, running that. Yes. Hit the notch on that, and we're going to go over on R2. Give us a host name for identity purposes. Call it R2. Address. Nope. We're going to go into our interface 0/1 mode, and we're going to add an IP address there, which is going to be no shot there. So that's our first link up and running, and we can confirm that it's up and running by going back here and doing a show IP interface brief. As you can see now, our link has an IP address and then an up state. Also, we can ping across the link to make sure we have connectivity, which is IP address on the other link is 10.0.0.2, and there we go. We have a success rate of 100%. Let's do the same over here. There we go. So we have connection between between R1 and R2. So now we're going to configure IP addresses on all the other links, R1, R2, and R3. So let's jump back over on R1. Let's give this a host name to identify our router that we're working in. And interface 0.0.0 IP address 30.0.2. Okay, we have one other link on up and running. Now let's jump right into our next serial interface. IP address. Jump on over to R1. Okay, so now we have all the links up and running, as you can see here from our diagram. And we can also confirm this by doing from R1 we can start by doing a do show IP route, and we can see that all our local configured ports and IP addresses are in our routing table. So we have our 10.0 network and our 30.0 network, same on R3, do show IP route, 20.0 network, 30.0 network, and on R2 do the same. Do show IP route. You can see here 10.0 network, 20.0 network. Okay, moving on to our Ospf configuration, and that we have all interfaces configured, all necessary interfaces configured with IP address. Let's start with our Ospf configuration. So I'm going to head back to our enable mode, and we're going to head into global config. And what I'm going to do, I'm going to type router Ospf, and then we're going to put in an Ospf ID, and the Ospf ID, the process ID that we're going to use is 1. It doesn't have to be 1, it could be between 1000 to 65,535, but I'm going to use 1 for this process. Then I'm going to add in our local network, and that 0.0 wildcard Mars 0.0.255. I'm going to use an area of 0. Since this is a single area Ospf, we're configuring all the areas on these router Ospf that we're going to configure is going to be area 0. So now if I went over to R2 and I also configured that already in global config, so all we gotta do is do a router Ospf1, and also we're gonna put that same network 10.0 network 0.255 area 0. We should form a neighbor adjacency, Ospf adjacency, which is right here. You got the message on here, and we should also got that message on R1. There we go. But what you're gonna see is that with a do show IP route, we're not gonna see any routes being learned via Ospf. That's because the routes that were placed in our Ospf database just now is already on a connected route, which is 10.0. What we're going to prove to show that Ospf is working is that we're going to learn our 30.0 or 0 network. R2 is going to learn our 30.0 network because, as you can see, it's not a locally configured network there. So same on R1. R1 doesn't know about 20.0, and R3 doesn't know about 10.0 network because they're not directly connected. And this is the job of Ospf to actually advertise the routes that they know about, each route know about, to all the routers that don't know about those routes. So we're still in, we're going to head back to R1. Well, we don't have to head back to R1 yet. We can just go back to R2 because R1 doesn't know about 20.0. What I can do is add that to R2, and R2 will broadcast its connected route to R1. So as you can see, R1 doesn't know about the 20.0 network yet, but we've already had an adjacency between R1 and R2. So once we go back to R2 and add in the network 20.0.0, so add in our card mask and wait a bit to show IP route again. As you can see, it's now learning about our 20.0 network. And of course we have our our cost and metric right here, and it tells you the IP address it's learning it from and the serial interface. So it's learning from serial 0/0 on R1 via the IP address 10.0.2, which is on 0/0/1 over on R2. Now it's the same for R2. R2 doesn't know about 30.0. But if I went over to R1 and do a configure, well, I don't have to do that. I do a network 30.0.0 before we actually apply that configuration. I head back over to R2 and do show IP route. R2 doesn't know about the 30.0 network. But once I head over to R1 and I apply that configuration, it should advertise it to R2. So I do show IP route again. As you can see, it's now learning about the 30.0 network. And let's learn about it via our 10.0.1, which is configured on 0/0/0, via 0/0/1, which is a local interface 0/0/1 on R2. Now R3 doesn't know about anything because Ospf hasn't been configured. It only knows its local route, so it hasn't built any Ospf database tables yet. So what we're going to do now is going to exit back into global config mode and create our Ospf process ID. I'm going to input. If we put input one of any of our local networks, it should learn of the route, which is 10.0.0, because on R2 and R1 we already added in all their local routes. So if we input 30.0 into R3, it will learn the route via R1, and if we input 20.0, it will learn 10.0 network via R2. So we're going to use the 20.0 network local route in our database. But before that, let's copy this. Let's cancel all that. Let's do show IP route again, just to make sure. As you can see, it doesn't know anything about 10.0. Once you paste back the configurations we just copied, we got our adjacency to be made right there between R3 and R2, or Ospf adjacency. To do a show IP route, as you can see, let's learn about the 10.0 network now. And that's it. The bare minimum for Ospf to work. Now to recap, the only thing that we need is all our interfaces to be up and working, and they have IP addresses assigned to them so that they can ping from point to point. Once that is done, we need a Ospf to be configured, Ospf process ID, and then the networks, the local networks that you want to share remotely with the other routers. Once we have our neighbor adjacency between the local routers, then we will start having routes being pushed around to other remote routers eventually. And then we have our network basically being converged from that point onward. And that would be it. Thank you for watching. Until next time.